So now in 5 through 10, we are going to do some more elaborate examples. Now we actually want to simplify each expression. So I'm doing 6 to the 4th times negative 2x to the 10th. So remember, commutative property of multiplication says that I can rewrite this as 6 times negative 2 times x to the 4th times x to the 10th. Now this step is not required, but I thought it would be helpful to show you how you should approach this problem if you do it in your head. So 6 multiplied by negative 2 is negative 12, and 4 plus 10 makes x to the 14th power. So you could have skipped this step and went straight to this final answer if you saw it in your mind. So number 6, once again, this becomes negative 5 times negative 2 times negative 6 multiplied by a to the 6 times a to the 1, right? Because there's a 1 if there's no exponent written, times a to the negative 2. So now I can simplify my answer. Negative 5 times negative 2 is 10, times negative 6 is negative 60. And now I add my exponents here. 6 plus 1 is 7, minus 2, a to the 5th. So now for the rest of these, I'm not going to rewrite it. I'm just going to do the problem. So 4 times 3 times 2, what is that? 4 times 3 is 12. Well, actually, let me rewrite this one. So this is 4 times 3 times 2, all right? And then I have c times c cubed, and then I have times d to the 5th. So I decided to rewrite this one just because now there is more than just 2 terms, and it might be helpful for you to group like this to see what actually goes together. So 4 times 3 is 12, times 2 is 24. C is c to the 1st power. 1 plus 3 makes c to the 4th, and d to the 5th stays the same. Now notice when you write these terms, it's usually in alphabetical order. If you have more than one variable, c comes before d in the alphabet, so c to the 4th should come before d to the 5th in my final answer. So I'm going to keep it going with separating numbers. So what number is this? Negative in front of my j. That's the same as negative 1 multiplied by 3 for all my coefficients. And then I have j to the 9th times j, oh not g, times j to the negative 3. And then the last thing I have is k to the negative 5. So negative 1 times 3 is negative 9. 9 plus negative 3 makes j to the 6th. And then I have k to the negative 5. Now remember, this is not simplified if it has a negative exponent. So I'm going to take this one and move it down to my denominator. So put this over 1, take this term, move it down. So now my final answer is negative 9 j to the 6th over k to the positive 5 power. So we do not leave negative exponents in our answer. A couple more to go. Of course, we have to deal with fractions. You can't get away from them even with exponents. So I'm using the same property. This becomes 1/2 plus 1/2 plus 1/2, which is a to the 3 over 2 power. We can do that. You can leave improper fractions for your powers. So now for part 10, 3 times 3 first. And then I have a to the 1/2, a to the 3/4, and then I have b to the 1/5, b to the 2/5. Okay, so now I can simplify my answer. 3 times 3 is 9. Now I'm trying to add 1/2 plus 3/4. So let me do that off to the side here. 1/2 plus 3/4 for these exponents. I need common denominators. I'm going to multiply this by 2. So I have 2 over 4 plus 3 over 4, which makes a to the 5 over 4. And now b is nice because they have common denominators. 1/5 plus 2/5 makes b to the 3/5. So keep in mind when you're adding exponents and their fractions, you might need to do common denominators. So we will practice this property in class together.